AlgIIB 2 students, how you doing today? I'm shooting a video for you on 8.2 A and B. We are going to be working out these problems together. I'm not going to be working out the problems on the sheet here where you see them. I'm going to be going to blank pages just to give myself more room. So on 8.2A, you are more than welcome to read all of this information that you see here. And what we're going to be doing is we're going to be simplifying expressions, rational expressions. That is a fraction with a polynomial in the numerator and the denominator. So today we're just going to be simplifying rational expressions, and then for 8.2b we will be multiplying and dividing rational expressions. So let's take a look here. Let's look at problem number 1. They are also asking what x is not defined, what x cannot be, and that would be an x that makes the denominator 0. So we're going to write that right here, is that rational expressions are undefined, so a denominator cannot equal 0. So we are going to find the x where that happens and make sure to take that out of our answers. So the way that we simplify rational expressions and to find the x's that make the denominator 0 so we can say that we can't have those x's is by factoring. So when you take a look on number 1, I think I will write for number 1 right here because they already did so much work for us. So the numerator factors to x plus 1, x minus 3 by some factoring methods for quadratics you've already learned. The denominator factors to x plus 1 and x plus 5. So notice the first thing we're actually going to do before we start crossing things out is put what x cannot equals. So when you take a look at the denominator, here's what we know. We know that x plus 1 cannot equal 0. This factor right here. Because if x plus 1 equals 0, then 0 times anything gives us 0. We cannot have the denominator be 0. Also, x plus 5 cannot be 0. So let's first find out what x cannot be for the first factor by subtracting 1 from both sides. X cannot be a negative 1. Notice if you try to put negative 1 into the denominator right here, negative 1 plus 1 is 0. 0 times anything is 0. We cannot have it. Also, x plus 5 cannot be 0. So x plus 5 cannot be 0. Notice when we subtract a 5 from both sides, we get that x cannot be negative 5. Again, when you take a look here, you can see that if you try to put a negative 5 into the denominator, negative 5 plus 5 is 0, and we cannot have that denominator be 0. Now in red, let's go ahead and simplify. Anything divided by itself is 1. We are going to cross out the x plus 1's, and our final simplified answer is the rational expression x minus 3 over x plus 5, and x cannot be negative 1 and it cannot be negative 5. Okay, let's take a look here. Let's first at number 2. First, let's find out what x cannot be. Notice that the denominator 4x cubed cannot be 0. Let's divide both sides by 4. We get x cubed cannot be 0. And let's take the cube root. And the cube root of 0 is 0. So x cannot be 0. Let's do a quick check. If you try to put a 0 into this denominator, 0 cubed is 0 times 4. We cannot have that denominator be 0. Let's simplify now. Let's first do the coefficients. 20 divided by 4 simplifies to 5. And x to the 9th divided by x cubed, we know that when bases are the same and they're being divided, we subtract the exponents. And there's our simplified answer. Let's take a look here at number 3. I am going to go to another piece of paper for number 3. So let's go ahead and write that. Give ourselves some room. X squared minus 4x over x squared minus 5x plus 4. And we have what x cannot be equal to. We also have to simplify and say what x cannot be equal to. Okay, let's factor the numerator. So the numerator has a greatest common factor of x and leaves an x minus 4. The denominator, because we just have an x squared with no coefficient, we can say that we're looking for two numbers that multiply to a positive 4 and add to a negative 5. That would be x minus 1, x minus 4. Let's do a quick check. Negative 1 times negative 4 is a positive 4. And of course we have our x squared, and we have a negative 4x and negative 1x for a negative 5x. Now I can see really clear that x minus 1 cannot be 0. And notice that we will take the opposite number for x. X cannot be 1, because 1 minus 1 is 0. Take a look, x minus 4 can't be 0. 4 minus 4, we cannot have 4. So you're welcome to set each factor in the denominator not equal to 0 and solving for x, but you get pretty good at just looking at the denominator and saying the opposite x that you see. Let's simplify our expression. The x minus 4's cancel, and we are left with x over x minus 1. Please notice you cannot cancel the x from the numerator and denominator. You would have to be able to factor in x from everything, and you cannot. Number 4 on our paper, right here, they're asking us to solve this equation. So I will write that here. 2x squared plus 7x minus 15 and 2x minus 3 equals 10. First of all, let's take a look at what x cannot be. This one is a little bit harder to see, so I actually am going to say my denominator, 2x minus 3, cannot be equal to 0. And I'm going to solve this one. I'm going to add a 3 to both sides. Here we go. And divide by 2. X cannot be 3/2. All right. Now let's go ahead and factor our numerator. That looks like that takes a little bit more too, right? So we're going to use our x method here. Let's take a look. We are looking for two numbers that multiply to a negative 30 and add to a 7. We'll put a 2x and a 2x. So two numbers that multiply to a negative 30 and add to a positive 7. Let's see, that would be 10 and 3, and the 3 would be negative. All right? So 2x over negative 3 is fine like it is, but here 2x over 10, we can actually cancel a 2. And so our factors in our numerator are x plus 5, 2x minus 3. The denominator is 2x minus 3 equals 10. Notice 2x minus 3 cancels out. We're left with x plus 5 equals 10, and you can see that x must be 5, because 5 plus 5 is 10. So our solution is x equals 5. All right. Let's go to 8.2b. For 8.2b, we are actually going to be multiplying and dividing rational expressions. And in this case, we're not going to worry about where the denominator is undefined. We're just going to work on the multiplication and division that we have. Okay, we have a lot going on here and not enough room to do it, so we're going to be doing this all on separate paper. So notice when we multiply fractions, we multiply across the numerator and the denominator, and then of course we would want to simplify those fractions. Any term that is the same in the numerator and denominator, we can cancel. So we can multiply first across the numerators and denominators, and then we could cancel factors that are the same, but that would create some really difficult multiplications. Take a look at number 5. if you multiplied out these denominators, that's a lot of work and it's going to be very messy. So we always cancel first. So we factor if possible, factor, then cancel, and then multiply. This is what I always do rather than factor, multiply, and cancel. It just makes for simpler multiplications, and then you don't have to cancel after. On 7, 8, and 9, these are division problems, but again, all we're going to do is keep the first fraction and multiply by the reciprocal, and we're back to actually doing multiplication problems. So here we go. Number 4. Let's work through this. So we have 12x to the 5th, y squared. While I'm writing this out, let me just say that one thing you really want to do is be really neat, because it's really possible that if you're not neat enough, that you could actually do the right work, but it's not neat enough for you to read. Okay, let's start canceling. Let's look at the numbers first. 12 and 6, the 6 cancels and leaves a 2. There we go. 3 and 9, the 3 cancels and leaves a 3. I'm looking for any other canceling. I don't see it. Let's go to the x's. I have an x squared in the denominator, and these two x's will cancel and leave an x cubed in this numerator. Okay, still looking for x's. This x squared right here will cancel and leave just an x here in the numerator. Again, there we go. There are no more x's in the denominator, so I can't cancel any in the numerator. Let's look at our y's. I have 2 y's in the numerator, and it cancels and leaves 2 y's in this denominator. Okay, I have 1 y in this numerator that cancels and leaves 1 y in this denominator. Notice again, when you look across the numerator, there's no more y's, so I cannot cancel any y's in the denominator. All right, so I think I'm ready to multiply. Let's take a look at our numbers in the numerator. 2 times 3 in red. Let's see how many x's we have. I have 1 x here and 3 here for a total of 4. Do I have any y's in the numerator? I do not. Let's check our denominator. Let's see. Any numbers? Any constants? No. Any x's? No. Y's? I have 1 here, 3 here for y to the 4th. Now, if I got done and found I had some more canceling I could have done, that would be okay. Number 5, 2x minus 2 over x plus 4 times x squared plus 4x over x squared minus 3x plus 2. Let's do all of our factoring. Oopsie daisy. I just moved it. Let's make sure you can still see. That's better. Okay. Let's look at number 5. Okay, I'm going to factor the first numerator on the left. I'm going to greatest common factor of 2. I don't see any factoring in the denominator on the left. Numerator on the right, I see I can factor an x, and that would leave x plus 4. The denominator on the right, I have an x squared. So I have x's, and I'm looking for 2 numbers that multiply to a positive 2 and add to a negative 3. That's a negative 2 and a negative 1. Again, you can see how much factoring quickly can help you now. Let's take a look. Let's see what cancels. X plus 4, numerator, denominator. X minus 2, numerator, denominator. Please notice this x in the numerator cannot cancel this factor of x minus 1 in the denominator. They have to be the exact same factors. So I believe what I have left is 2x in the numerator and x minus 1 in the denominator, and I don't see any more canceling that I missed. Let's do number 6. 8x plus 16, x squared minus 1. Oh, that will be our first difference of squares, right? We're used to that pattern. Okay, let's factor. Numerator on the left, greatest common factor of 8. Denominator on the left, difference of squares, that factors to x minus 1, x plus 1, right? When you do the square roots, times the numerator on the right does not factor, and the denominator on the right has a greatest common factor of 4. All right, let's cancel. X plus 1 numerator, denominator, x plus 2 numerator and denominator, a 4 in the denominator cancels from the 8 and leaves a 2. I think I'm done. I think I have a 2 in the numerator and an x minus 1 in the denominator. Final answer. Awesome. Let's move on to the division problems. So if it's okay with you, save myself some time, take a look at these division problems. So you see them on your paper. So when I write number 7, I'm going to keep the first fraction, put a multiplication sign, and flip the second fraction from what you see on the paper. I'm going to do that for each problem to save room and time since you see the division problem. So here we go. Number 7, 3x cubed y, 5xy squared. I'm going to multiply, and I'm going to put the 15y in the numerator and the 9xy cubed in the denominator. Let's start our canceling. Let's look at the numbers. This 5 cancels and leaves a 3 from the 15, right? This 3 cancels in the numerator and leaves a 3 in the denominator from the 9. And I can cancel a 3 from the numerator and denominator. I believe all my constants are gone. Let's check the x's. This 1x in the denominator cancels 1 from the x cubed and leaves an x squared. This 1x in the denominator on the right cancels more from the x squared and leaves an x. I have no more x's in the denominator, so I can't cancel anymore. Let's take a look. This y in the numerator cancels 1 in the denominator. This y in the numerator cancels this y. And I have no more y's left in the numerator, and so I can't cancel anymore. Let's see if I was neat enough to see what's left. I see an x left in the numerator and a y cubed in the denominator. And here is our final answer. Let me give one more quick check on my neatness. I did okay. Number 8, I am going to keep my first fraction that you see on your paper, and I'm going to write multiplication and division, and I'm going to write x plus 2 in my numerator and 3x in my denominator, flipped from the paper, of course. Let's go ahead and factor where we can. Numerator on the left, greatest common factor of 4. Denominator on the left, that would be the difference of squares, x minus 2, x plus 2. Numerator on the right, I see no factoring, and same with the denominator on the right. Let's do our canceling. X minus 2 cancels, x plus 2 cancels, and I believe we are left with 4 over 3x. Excellent. Last one. Number 9. I'm going to keep my first fraction. I'm going to write multiplication instead of division, and the denominator on the paper I'm going to put in the numerator, and the numerator I'm going to put in the denominator. All right, lots of factoring here. Here we go. Top left numerator, I have an x squared, so I just need my x's. Two numbers that multiply to a negative 3 and add to 2, positive 3 and negative 1. Difference of squares in the denominator on the left, x minus 3, x plus 3. Right, when you do your square roots. Numerator on the right. Two numbers, I've got my x squared, so x and x. Two numbers that multiply to negative 3 and add to negative 2, that would be a negative 3 and a positive 1. Denominator on the right, I've got x squared, so just x and x. Two numbers that multiply to negative 4 and add to 3, let's see, positive 4 and negative 1. Excellent. Let's do our canceling. X plus 3's. What else? X minus 3's. Excellent. X minus 1's. It kind of feels like cleaning. I love it. And I am left with an x plus 1 and an x plus 4 in the denominator. Again, I cannot cancel those x's. This is a factor of x plus 1 and a factor of x plus 4, and they are not exactly the same, and I cannot cancel them. I hope you have a wonderful day.